Good morning everyone. I am Amrutha from final year czbt. Today I am going to talk on production of Polyhydroxy Alkaloids and Xanthan. What are microbial polymers? The polymers which are produced by the bacterium or the microbes. Like there are many polymers that have been produced by the microorganisms which are of commercial use due to their various material properties and chemical properties. And what are the biological function of these polymers? In the sense they act as reserve materials and protective capsules, and also has storage functions and biofilm matrix which helps for adhesion. There are many category of polymers, microbial polymers, that they are polysaccharides, polyesters and inorganic polyhydroxybutyrates. There are several polymers, but only polysaccharides and polyesters have been commercially produced due to their various properties. Coming to microbial polysaccharides. Microbial polysaccharides are the polysaccharides produced by the bacteria around its cell surface in the form of capsules or slimes. These are the carbohydrate units which helps in production and also acts as a barrier and storage. Example: cellulose, starch and xanthan gum and alginate. Coming to cellulose. Cellulose is a linear homopolymer which has glucose units as a monomeric unit, and it helps in floating and also storage. Acetobacterium species produce these cellulose, and you can see the structure here. They are linked by beta 1,4 linkage, and all of them are glucose units. So monomer is glucose units, and these cellulose are cheaper and also has more efficiency than the cellulose which is produced by the wood pulp. And alginate. Alginate is a sulfated heteropolysaccharide, and the monomeric unit here are like D-gluconoric acid and D-malonic acid, which is linked by again beta 1,4 linkage. These are of various use, like they help in thickening and gelling agent in dairy products and also as food stabilizers. And again acetobacteria species produce these alginate. Next is xanthan gum. Xanthan gum has higher molecular weight, that is 1.5 to 10 to the power of 6 daltons, and the species which produce these xanthan gum are Xanthomonas campestris. It is a heterocyclic polymer. It has glucose units, mannose units and gluconoric acid units. Production of xanthan gum, and mainly it starts with the media preparation, and the media preparation needs the carbon source. The carbon source can be starch, glucose or corn syrup or molasses, and then the nitrogen source. Nitrogen source may be casing of milk or soybean flour or peptonuria or ammonium chloride. And the traces of magnesium chloride is also required, hence the magnesium chloride in phosphate buffer is added to the media. The pH maintained here is the neutral pH, that is 7. Firstly, the bacterium is cultured in the enriched media, and then it is used as an inoculant for the large scale production. Once the stationary phase is reached, that is the bacteria will not utilize the nutrients and nor it will divide. At that stage, the broth or the media is subjected to pasteurization to 100 degree to 110 degrees Celsius for 10 minutes to kill the bacteria. And for the precipitation, that is the removal of cell is done by using isopropyl alcohol. And then for further purification, filtration, centrifugation methods are used, and then it is packed, dried, dehydrated, and packed as a granular powder. Applications of xanthan gum. Xanthan gum has various applications, like it is used as a stabilizer for paints and also as a food additives, and also as a carrier for fertilizers like herbicides and insecticides. It also has the adhesive property, hence it is used as thick adhesive and also as thickener in textile dyes. Next, coming to microbial polyesters. These are the esters produced by the bacteria. The major important polyesters are polyhydroxy alkaloids, that is PHAs. This is the only commercially produced polyester. As these are grown only if there is limitations in the with respect to nutrition or the stress condition in case of bacteria. Polyhydroxy alkaloids are formed by the fermentation of sugars or lipids, and there are many polyhydroxy alkaloids. That there are polyhydroxybutyrate and polyhydroxylactic acid and many more. As they are ductile and elastic, and they are also soluble in halogenated solvents, that are chloroform or dichloroether and many other solvents. Hence, it is of great commercial importance. The monomer here is the same for all. It will be similar for all the PHAs. Almost all the PHAs, the monomeric unit will be the same as it is seen here. Then here we'll study about polyhydroxybutyrate corruption mainly. Before going to that, polyhydroxybutyrate are produced by the condensation of acetyl-CoA to acetoacetyl-CoA, and then reduced to beta-hydroxybutyrate CoA, and then it is polymerized to 10,000 units to get polyhydroxybutyrate. These PHB resemble polypropylene in properties like melting point and other things, molecular weight and all. It is inflexible and hard bioplastics, hence it has great commercial importance. Production, it is synthesized by Ralstonia eutropha species, and firstly it is grown on the fermenter which is rich with carbon source, and then the stress conditions are provided like low concentration of oxygen and less amount of nitrogen, phosphorus and magnesium and other things. It is produced only when there is a stress condition, as I have mentioned this earlier. They are then extracted from the halogenated solvents. Applications of PHAs, they are of various uses. As I said, it is used as a bioplastic, and it is used in replace between petroleum-derived plastics, and also it is used as implant materials like in medicine, like screws and anchors and pins, as it will get degraded inside the body within 7 months to 2 years. It will degrade, hence it is used as screws and anchors in medicine or in surgery, and it is also used as biofuels, and mainly it is used as drug